Hi guys. So in this video we'll be discussing about how can you calculate the square root of a number. Okay, so there are multiple ways to calculate a square root of a number, but it's like without using maths library. Like you cannot use math.sqrt. So there is a function, if you know, math.sqrt. With the help of this math.sqrt function, you can directly calculate the square root of a number. But the interviewer will tell you, like, I don't want to use this math.sqrt function. Without using this function, you have to calculate the square root of a number. Then how can you calculate that? So there is a specific algorithm for that. Okay. So first we will learn the brute force approach, like how can you approach it with a brute force algorithm. Okay. So first of all, what we have to do, first of all we have to run a loop. Okay, for int I equal to 1, I less than equal to n, I plus plus. Okay, so any number I am considering, let's suppose I am considering 4. Okay, I am considering 4 now. So is 4 is a square or not? So first of all we have to check, we have to calculate the square root of a number. So what we have to do here, first within that we have to check if I into I. Okay, if I into I is equal to n, which is the given number, let's suppose n is the given number, and for that value we have to calculate the square root. Okay, so n is 4, so if I into I is equal to n, so condition will get satisfied. So here I will return that I. Okay, I will return I from here. Okay, so this is the way we can calculate a square root. But let's suppose there is a number which is not a square root. Let's suppose the number is 5. Okay, so in that scenario, what will be the square root? It will be 2 point something. Okay, it will be 2 point something square root of 5. So what we have, then we have to calculate the floor value. Okay, we have to calculate a floor value. So it will be 2 itself. Okay, so because 5 lies between 4 and 9, so there are two squares. Like first square number is 4 and the square number is 9. So 5 lies in between 4 and 9. So any number lying between 4 and 9, it will have the square root of 2 point something. So I will calculate the floor value. So floor value will be 2 only. So any number lying between 4 and 9 will have the square root of 2 only. We have to calculate it in such a way. Okay. So what we have to do? So for that we have to take one answer variable. Okay, so we have to take one answer variable. So int answer, okay, equal to -1. Let's suppose I am putting answer as -1. So now what we have to do, we have to check whether I into I is less than equal to n or not. Okay, so if I into I is less than equal to n, so condition, if it gets satisfied, then I will update my answer. Okay, so answer variable will be updated here. Answer will be equal to I. Okay, so till here, till less than equal to n condition is there, then answer will be equal to I. Else, okay, else we have to break it. We have to break from this loop. Why we have to break from this loop? So let's suppose I am considering one scenario. Let's suppose n is 5 now. Okay, so let me write it here. So let's suppose n is 5. Okay, so 1 less than 5, condition satisfied. Answer is -1 now. So if I into I, 1 into 1 is less than equal to 9, less than equal to 5. Yes, condition is satisfied. So answer will be equal to what? 1. Okay, and it will go next. I will be equal to 2 now. So 2 into 2 is less than equal to 5. Yes, condition is satisfied. So 2 into 2, I will be equal to 2 now. Okay, so 2 into 2 is 4. 4 less than equal to 5. Condition is true. So answer will become now 2. Okay, so now in the next step, what we have to do, I will be incremented by 1. So I will be now 3. I will be 3 now. So now 3 into 3, if you see, 3 into 3 is 9. 9 will become greater than the given number 5, whose square root I have to calculate. So it will become greater than 9. So this if condition will get false. So it will go to the else part. And in else part, it will break. And I will return the answer from here. Okay. I will return my answer from outside this for loop. I am returning my answer from here. So like this, if I do, then what will happen? I will calculate the square root of a number, and if number is not a perfect square, I will calculate the floor value of that. Okay. So like this we can calculate, but what will be the time complexity? By going this way, the time complexity for calculating the square root will be O of under root of n. Okay, O of square root of n. Okay, so why square root of n? Because it is going squared times. So 1, then 2, 2 into 2, 4, okay, then 3 into 3, 9, then 4 into 4, 16. So in a squared manner it is going, in a square root times it will go. It will not go in a linear fashion like 1, 2, 3, 4, 5. So time complexity will be O of root n, okay. So now is there any possibility to reduce this time complexity? Yes, we can reduce this time complexity from O of root n to O of log n. Okay, there is a chance, there is a way. How can you reduce this time complexity? So log of n is very great time complexity as compared to O of root n. So how can we do that? So we can reduce this time complexity with the help of binary search algorithm. Okay, so this same algorithm, here we are not searching, here we are checking whether the condition is satisfied or not to calculate a square root. But in binary search, how binary search works? So let's get into that. So let me delete this part. Okay, so now what we have to do now? Now we have to implement a binary search. So now we have to think like, what is a binary search? Binary search means it works like a dictionary. So in dictionary, if you have to search for a certain word, let's suppose you are searching for hello. Okay, so how will you search for hello? You will not go page by page. Okay, so you will think like, I will go in the middle first. Okay, and I will see whether what letter is coming, what character is coming. So if it is coming close to H, okay, you think like how you see for a word, how you look for a word in a dictionary. You search for a specific character, first letter character, and you will check whether it is equal to H or not, the hello part, H part of hello. Okay, so if it is less, you will go further, and if it is more than H, if any character is coming which is greater than H, then you have to go backwards so that you come closer to your first character of hello, which is H. So like that binary search works. Same process, like you look for a specific word in a dictionary. Okay, same process you will apply in binary search. So how that concept will be applied here? So that will be understanding now. So first of all, what we have to do, we have to calculate the square root of a number. Okay, the square root of a number, let's suppose I want to calculate the square root of 4. I will go with the perfect square number now. So now how we can go? It will be like 1, 2, 3, 4. Okay, from 1 till 4 I have to go. So first number will be my, what will be my first number? It will be my start. This will be my start. Okay, first number will be the start and the last number will be my end. Okay, so what will be my mid value? Mid value will be start plus end by 2. So it will be 1 plus 4, 5 by 2, it's 2.5. So seal value will be 2. Floor value will be 2. So here it will be, this will be my mid. Okay, this will be my mid. So here you can see, now we will do the square here. Okay, I will do 2 into 2. So 2 into 2 is equal to 4. Yes, 2 into 2 is equal to 4. Condition gets satisfied. I will return this I from here. I will return it. I will return this I, which is 2. And you will get the answer. So how fast it is, right? It's O of log n time complexity. Okay, it's log n, it's so fast. Okay, so now here it was 4, so it was perfect square, so we can calculate it very easily. But what if we are taking number as 8? Okay, 8 is not a perfect square, so how can we calculate a perfect square for this number? So I have to go till 5, 6, 7, 8. So I have to reduce it a bit. Okay, so here what we have to do, I will take 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now 1 will be my start. Okay, so 1 will be my start and 8 will be my end. Okay, so now how can we calculate the middle part here? It's 1 plus 8 by 2. 9 by 2 is 4.5, which is 4. So I will consider this as my middle. Okay, so 4 is my middle part. So now I have to calculate the square root of 8. So now I will do the square of this number. So 4 square. 4 square is greater than 8, correct? 4 square is 16, which is greater than 8. So what I will do now? I have found a number which is greater than 8. So I want to know the square root of 8, right? So I have to go closer to my number. So to go closer to this number, I have to reduce this end part. Okay, so I have to reduce this end part. So what we have to do, end will now come here. Okay, and binary search will work on a sorted array, that we have to understand. The arrays should be sorted, then only we can find the binary search. So here it is a number and we are going from 1 to 8, so it's by default sorted in ascending order, so we don't have to do anything regarding sorting here. So we have to go closer to the value, so end will come here now. Okay, end will be removed from here, and now end will become, my new end will become 7. Okay, so now my mid will change. What is my mid now? It will be 7 plus 1, 8 by 2 is 4. Still it will be 4 only. So same mid will be there. So now it will be checking if 4 square is less than 8 or not. No, it's not less than 8. So again we have to reduce this end value. Okay, so this end will be reduced by again 1. So end will be equal to mid minus 1. So this will become my new end. 6 will become my new end now. Then what we have to do? Again we have to calculate the mid value. So what is my new mid value? So it will be like 1 plus 6. 7 by 2 it's 3.5. So this will become my new mid. This will become my new mid. Okay, so now I will check again. 3 square is greater than 8 or less than 8? It's greater than 8. Okay, so I have to come closer to or less than equal to 8. Okay, so for that what we have to do? Again we have to reduce the end. Again I will reduce the end by 1. So it will now point to 5. So now start is same only, start is not changing, end is changing. So it will calculate a mid. So it's 5 plus 1, 6 by 2, 3. So again it will point to 3 only. So 3 square is greater than 8. So again mid will change here. Okay, so again it will become point to 4. This will become my new end. 4 will become my new end. Okay, so now what will be my mid here? So my mid value will change to 4 plus 1, 5 by 2 is 2. Okay, so it will come here. This will be my mid. Again I will check. 2 square is greater than 8 or less than 8? 2 square is less than 8. 4 is less than 8. My condition gets satisfied. So now what we have to do? I have to go closer to 8. Okay, so to go closer to 8, what we have to do? I have to update my start to mid plus 1. Okay, so now what I will do? I will update my start to mid plus 1. So now this will become my start. End will be at same position. End will not be changing now because I have to go closer to it. Okay, so now we have to calculate a new mid now. So new mid will be what? 4 plus 3 is 7. 7 by 2 is 3. Okay, so now mid will be changing to start position. Now mid will be pointing to the start position only. 4 plus 3 by 2 is 3 only. So now mid will point to 3 only. So now it will check 3 square. Okay, so 3 square is greater than 9. So greater than 8. Okay, 3 square is greater than my given number 8. So what we have to do? I have to come closer. Okay, so end will be changing here. Okay, I have to come closer, right? So this now end will point to 3 only. End will now point to 3 only. So now what will be my mid here? So mid will become my same start plus end. 3 plus 3 6 by 2 is 3 only. Okay, so 6 is coming, right? So 3 square is greater than 8. Okay, it is greater than 8. So end will be coming here now. End will be coming here. So here you can see start is becoming greater than end value. Okay, so during that time, what is my mid value? So my mid value is 3 now. Okay, so now 3 is not my answer. Okay, so 3 square is 9. So 3 square is greater than my current value 8. So I have to return this 2, which is the past value. Okay, so I will return 2 from here. Okay, so this is the entire process which is going on in the backend. Okay, so to calculate this, so start will be this, end will be this, and it will keep on moving further, and it will calculate what is my square root of a number. Okay, so for this, what code we have to write? We have to write while start is less than end, start is less than equal to end. What we have to do in this? We have to check first condition ki whether if array at sorry, there is no array, there is only mid value here. So we have to calculate the mid value first. Okay, so mid will be equal to, either you can do like start plus n by 2, but if number is very big, then it will throw some exception because it will be like out of range. So in that case, what we have to do, we have to do start plus n minus start by 2. Start plus n minus start by 2, that will be my mid. If you calculate, it will come as start plus n by 2 only. Okay, so this is my mid. Then what we have to do here, we have to check whether if mid into mid is less than equal to n or not. Okay, so if mid into mid is less than equal to n, then we have to update my answer. Okay, I have to update my answer. Answer will become my mid value. Answer will become my mid value. And then again we have to check the left part. Okay, we have to check the left part and we have to check the right part. So if mid into mid is greater than n, then we have to come closer. So for this, answer will be equal to mid, and else part, what we have to do, in else if part, if mid into mid is greater than the given number n, then we have to come closer. Then in that scenario, n will be equal to mid minus 1. Okay, so like this we have to calculate the value. Okay, so at the end, what we have to do, whenever we have find it out this, where mid into mid is less than equal to n, we will store it in an answer. The answer will get updated continuously. Okay, so as soon as it goes further, n will be equal to mid minus 1, and this whole process will continue, and when you return the answer, you will get my middle value. So like this, it will calculate the square root of a number. Okay, using binary search. So it is logarithmic time complexity. So it is becoming more improved time complexity as compared to the normal brute force approach. So it is reduced from root of n to log of n. So it is very crucial and important algorithm to understand, and solves a lot of problems in just log of n time complexity. So I hope you understood the concept, you understood the problem. So we will see in the next lecture with the next set of concepts. Till then, bye bye.